All right, looks like we're recording.
All right.
All right, first video. New at doing this one. As far as social networking and discussing a couple things. So I'm Chris Marciniak, in the occupational health and safety engineering master's program. About to go into my final semester after the summertime. Industrial engineer with NJIT as well. Work in the capacity of a environmental health and safety manager for Morton Salt in Fairless Hills, Pennsylvania. But we support a bunch of other operations as well. Uh, I have David on the line with me as well. Go ahead, David.
All right. Yeah. Hello. I'm David Demjanic. I am getting working towards my master's in chemical engineering. I'm also on my last semester, so I should be finished at the winter semester here. I work currently at a roofing company called GAF in Parsippany, New Jersey. I do a lot of testing and formulation there as well. So we work a lot on working on the commercial side of roofing products and developing new formulations and new products to improve the field as well as cost savings and time.
All right, Dave. So, do you see this one article that's out there now? It's a first electric tanker equipped
Yeah.
going with lithium ion batteries. I believe it was out of the Mitsubishi company, right, out of Japan. I think it was E5 tanker, and it's gonna start long operation. It looks like what 2021 to 2040, but using all battery powered. They're using a little bit more technological advances to help improve some efficiency with the workers. What's your thoughts on this one? I had a couple mixed things, especially since the tanker
Yes,
is going to
yes,
be the refueling tanker.
right. I mean, so did I when I first read about it. I mean, I thought, hell, this is kind of like how Tesla, started up.
Hmm.
They first talked about, oh, we're gonna have electric cars, coming soon, and people thought they were crazy. And then look, now we have Teslas on the road, and they're trying to make it more efficient as they go. But it's up and running. They're still around. I
Hmm.
feel this could be the next Tesla. But for the the boating industry and cargos, because hell, they're a big source of pollution because they're
Oh
always
yeah.
traveling far distances. I mean, I think
Hmm.
they're worse than even airplanes that are flying around in regards to pollution because of the mass amount of weight they're carrying and the load they have. You
Yep.
know, this is great because if you could have a battery that could actually last a whole transit, like let's say from China to like the United States or
Hmm.
India to the United States or something. I mean, that's a large gap you're covering right there. And if they can make a battery that could hold that charge, I think that'll be a game changer. But
Yep.
I think realistically, it may be may happen would be they could have a few batteries on a tanker to hold it because I can't imagine a battery that could hold the whole charge from
Hmm.
one area of the continent to the next. Like I think that's mind blowing. If they could do that, that's incredible. I mean, there'll have to be some type of way to solar charge it as they go. But I mean,
Hmm.
that kind of leads into like, how are they charging these batteries?
Well, yeah.
How are they possibly charging these like mega gig batteries?
Well,
To
that's the
suffice this type of travel.
that's a little discrepancy that I have, and I love the fact of having electric cars that are out there, and people using alternative fuels. But at what point are you taking the pollution aspect from the engine and just bringing it back to the power company? So these batteries do have to be charged, and are we just moving the fossil fuel consumption from the household, or from the ship to those major production areas? Now I know Japan, they have high nuclear power capacity, but also too, you have to have a fairly decent infrastructure to be delivering these trickle charge powers. How long does it take to recharge too in port? Is
Yeah,
it is it gonna be
exactly,
is it gonna be
exactly.
fiscally responsible? And then what happens if there is an impact? Say the ship gets damaged and takes on water, ends up sinking. What's the environmental impact of these
Exactly.
batteries
That's it.
in the
That's
water?
exactly what I was gonna bring up as well because if, I may be incorrect, but I heard lithium batteries when it comes in contact with water, it corrodes very severely and it's pretty
Hmm.
toxic at that point. And as you mentioned, if the ship sinks, if you have these aren't small batteries at this point trying to cover the tanker. This is going to be huge batteries. So you have a huge lithium battery going to the ocean.
Hmm.
Like, are they going to try and recover this because of the toxic effects it's going to reduce to the water? Or are they just going to be like, well, we'll just try to work around this and try to correct it by doing some other alternative
Hmm.
ways to make our credit look better to the environment or something like that. Because that's a pretty severe thing. Because I'm sure we all know not all ships make it safely when they go to their destination. Some sink,
Hmm.
some are attacked by pirates. What if
Yeah.
the pirates start attacking the ship, just to take whatever's on board and run away with it? They could
Right.
damage the hull, and if the abandoned ship, that's all going to waste at that point. Yeah,
Yep.
the ship could be a part of the coral reefs. I know we do that as well with our old military ships. We blow it up, becomes a coral reef. That's
Hmm.
great. But I mean, there's nothing toxic or whatever that's going to be on those typical ships that they plan on destroying. This
Hmm.
one has a big ass lithium battery. That could be very harmful to the environment, and cause such an uproar to all the environmentalists out there.
Yeah, no, I would agree. I think that's a perfect segue going into our next one. We're going to talk about looking at electric cars. The robots could recharge wirelessly as they go. Bringing it from the sea to the land now. And I love the concept of this, as far as having that wireless control, or excuse me, recharge. Going from the roadway to cars. As we start to get more autonomous with our cars, regardless of not if it was fossil fuel consumption car or a battery powered car. I love the way the direction we're going with. A lot of autonomy with driving, taking putting a high safety factor in there. So I'd be curious to see over the years as we start to get this quantitative data if accidents start to reduce and people's lives, if there's less motor vehicle deaths and whatnot. But going back to this wirelessly recharge, it seemed like two engineers in what was it, Stanford, I think it was, electrical engineers and a graduate student, developed this. And you have cars of different sizes, different heights. You have different factors in there, but they're able to get something pretty consistently going across to do create a magnetic field that oscillates right in frequency. And they would change that resonant frequency too as the distance changed. The one thing I didn't like, and I don't know why I'm on the negative path today, but they're looking at the recharge, but they make no mention of they're adapting to the technology we have now. But why not have some type of ultra capacitor battery? We have carbon aerogels out now that are able to hold a high, farad capacity, and drive these vehicles. And I'd be curious to see if they would have a better, if there was more technology as far as deliverance in the batteries that are out there. Would this be more applicable? I don't know. What's your thoughts on that?
Yeah, I mean, it's fun. It's funny that we talk about this because I remember doing a paper exercise a few years back in regards to, like, something similar to this, where our goal was, we made basically we worked on basically highways, and what we did, we made panels that was basically kind of like a solar panel, but for highways, so that we could recharge Teslas
Mhm.
or whatnot as they drive on it. And it was similar to what these guys are talking about now, and it seems like we're that's kind of a great progression that we're going to now. But like you mentioned, there is a lot of factors you have to consider with that too, in regards to height and distance, because all cars are different. But also with speed wise, are they getting the right charge for the speed? Because they're not all, it's not go and stop, especially if you're on the highway. You're pretty much
Mhm.
going 50 miles an hour. But I mean, realistically, we're probably all going 70 miles an hour,
Yeah,
right?
yeah.
Going up there. They mentioned here, I believe it was like 50 or so miles per hour on the thing, and they said they could get a charge within 4 feet. They could
Yeah, yeah.
get a charge going, I believe. But I mean, we're going 20 miles over that by going at least 70, 75 easy on the
Hmm.
highway. So, like, is the charge going to still hit the battery? How is it working? Is it going to be with the battery? Is it going to be a separate junction that
Hmm.
kind of transfers within the front of the hood or the back of the hood, wherever they store all this equipment? There's got to be a way for it to properly get the maximum efficiency to recharge while still driving and getting to your end goal. Because
Hmm.
if you're going to stop and go, kind of how they're doing now at Tesla with these charging stations, I don't really know if it's going to be worth it putting all this effort into devising a plan like this. But on the bright side, though, it would be less costly than what we currently have, which is just concrete, because we know that
Hmm.
deteriorates in the 5 to 10 years, and
Yeah.
kind of, at least for me, the purpose of that just, it kind of keeps, job flow going because it brings consistency. You need people to always resurface. You need people to
Hmm.
redo it all, blah blah. Great for them, but if you want to go towards an aspect where we kind of create less waste, plus the fact that we don't have to have less maintenance to it. This is
Hmm.
a great way to do it. If we could just somehow make like a sheet that just goes along, and then if a panel is damaged or whatnot, great. You just lift the panel, use a little construction, boom, put it back. You don't have to redo the panel. You just have to kind of edit the or adjust or replace whatever parts for the
Right.
that's helping the solar generation send out the the charging. That's
Hmm.
what you have to generate, and that should be kind of simple depending on how they you know formulate their sheets, I guess.
Hmm.
But I mean, it is a great startup that someone's trying to really take advantage of this because especially with how we're progressing within the solar industry. I
Hmm.
mean, the percentages I think are probably is. I mean, they're pretty high right now. I mean, there's probably not much we can do to get higher than where we are. I
Hmm.
mean, great, obviously, on paper exercise, there probably is a way, but like, realistically, we're probably at our maximum,
Yeah.
efficiency of getting it. So, I mean, moving forward with what we have is definitely, the step in direction, especially with, all these different types of, electric generations that we're doing. As we just mentioned, we got boats going on now. Like that'd be interesting to see how they could
Hmm.
incorporate that with, those the tankers.
Yeah.
But the cars that we already currently have, I mean, you could, even go forward with getting motorcycles on board now.
Yeah.
I don't know,
Well,
and
think
then
about
especially
trains and whatnot too. You wouldn't have to draw from the grid. That might even be a better applicability because it's a constant one track. You have
right,
a metro system, a subway systems. They don't have to rely on that third rail. It might be something a little bit better.
right, yeah.
Yeah, no. So it's I though I'd be curious to see the risk factor on this though for what if somebody has a pacemaker or like something is it gonna affect cellular service or I know it wouldn't affect GPS but what are the adverse effects of something like this?
Or even what if like let's say for instance the electricity instead of charging, what if something got disconnected or something and ended up like turning the whole car off, or
Yeah,
even God forbid it exploded
or
because
overcharge.
because
Yeah.
yeah, like how do is there a way to avoid that? Are they gonna have like a surcharge sector
Hmm.
to prevent overcharge or something like that? That's also something that I would hope to believe they would have to consider in the long run once they devise this
Yeah.
type of magnetic field to recharge. Because otherwise, you can't just put it out there and then just kind of explore what everyone's doing. Because that's
Hmm.
just not sensible and won't really pan out in the long run. You got to kind of have information regarding everything and get all the data points.
Yeah,
So
exactly. Well, I think that leads us, again, we're doing pretty good with this one. Goes right into our risk management article that we're taking a look at. And I think this is something that's fairly fresh in our minds, especially with taking Dr. Olson's class last semester.
right,
And everything has an associated risk, and it's not just dealing with risk analysis with people or the harm to people, but it's also business continuity risk, environmental risk. I always treat things as 5 points of a star, right? You can't have a star without 5 points. So you always look at your health and safety, you look at your production, your quality, your environmental, and your reliability maintenance. They all get assigned some form of risk management, and what's the probability and what's the acceptable risk for you to take. Like we drive our cars, we know there's a risk in there, so we try to mitigate it by driving normal and putting on a seatbelt and using our blinker and whatnot. So the risk evaluation tasks and analysis haven't changed that much. I know they've been adapted more. Come post 9/11 now is higher frequency being integrated in, whether it be through an ISO process like integrating the ISO 18,000 and 39,000 risk management into ISO 45,001 from a health and safety standpoint. But how do you see this related in your field? I would think that there's a good business continuity risk on roofing and how the product quality is going to be. You know,
yes, yeah. So that ties kind of really right into it, especially when it goes to like when you're doing innovation. That's kind of where like, you're really getting into when you're doing innovation R
mm,
and D. You gotta set all those the boundaries, and what a high risk, low risk, medium risk. I mean, for us, it's kind of, I guess I don't want to say easier, but it's much simpler to find out the risk levels. I mean, when you go into like the medical field, I feel like they need to kind of like branch out even more
Mm,
because they have all these different types of things that go on and could go wrong. Whether it's in surgery or just on the floor. They have to have a broader spectrum for the risk analysis rather than a position like I'm doing where we're just doing kind of like R&D and improvement for like the roofing
hmm.
industry. We have a much smaller risk that is associated with it because all our risk mostly is kind of like supply chain,
Right,
human error, and stuff like that. It's nothing really too catastrophic because it's either you got the right piece that fits in like the puzzle, or you got to switch out the puzzle piece and get something else.
right.
Something with like the medical field. You're dealing with the human body. Everyone functions differently. Everyone
Hmm.
operates differently.
A lot of variables.
One twitch here is a different twitch for somebody else. So
Hmm.
they have a lot of different factors they have to incorporate, and I feel like they need a much broader um, risk analysis, but then also kind of goes into the fact that, just because it's low risk, it should be neglected. That's kind of
Right.
what the fear I have with some of these risk analysis type things is that, they see low on the category, like, okay, cool, low. That means what? It's
Hmm.
not really going to happen. Or, what's the worst going to happen? Someone's going to hurt their arm. Great. You don't have to focus on that. Well, let's
Hmm.
just do the high task because it's more important, severe. But I feel like, stuff that is low, if it happens over a certain amount of
Yeah.
time, that could build up and be it could be a medium and even a high risk.
Oh
But
yeah.
let's say, how I mentioned with my arm, let's say I hit I'm hurting my arm every day of the week for about 2 months.
Hmm.
That could be, instead of, me having an operation on my arm, I can't use my left arm anymore.
Hmm.
That's going to escalate it to a high risk issue because now, I got to go to physical therapy. The cost of, whatever repair needs to be done to my arm is
Yep.
going to be affected because that's going to go towards the not only my medical, but the company's going to have to take care of it because
Hmm.
they neglected this for so long. That's kind of the fear I have with all these low priorities that people try to situate, is that even though it's a low priority, it should also be based off of time wise. How
Right.
quick can this be fixed?
Hmm.
Is it something that's even though they have repealed the frequency on here as well, it
Hmm.
should still kind of you got to still factor in kind of like, I guess, the pain level as well. If it happens in the same spot all the time,
All the time. Yeah.
it's gonna generate. It could, I guess what I want to say is that there should be like a generation aspect to it where if it's repeated at a frequency, it could become from a low to a high
Right. There should be some
analysis.
some type of exponential or something.
Yeah, yeah,
After
yeah.
10, it gets bumped up to something else. Because it's like we just did training. I just conducted training on ergonomics and proper lifting, and it's somebody could be reaching and putting stuff on a piece of equipment and straining their back very minutely. But if they do that for 10 years all over the time, they may end up injuring their back the same as if somebody did one acute injury instantaneous by picking something up in a inappropriate way. So
Yeah, I mean,
it's
I have a great example with that because we get chemicals in all the time because we're
mhm,
doing, like I said, we're doing R&D experimental stuff, and usually they're like 50-pound bags that you're handling, and if, let's say, for instance, you're putting on a above a 5 foot shelf,
mhm,
great, I'm like 5'10", that's fine for me. You may think, oh, that's no problem, you should be able to do it, but depending on if you're doing a proper lifting technique and the way you place it, and if you have to like stretch to push it, all that is kind of a factoring that could bring, like you said, those minute hazards that are
mhm,
unnoticeable until that one day where I try to lift it and then something goes out my back or my arms maybe just give out and you're like, whoa, what
mhm.
happened? Then then you're basically gonna have to track all this previous data and find out what was the cause of this, and like, it's because it was a minor strain, but it
Mhm.
built up to now in a high risk territory where now you're
Right.
out of work because you can't function properly.
Yeah, you're using a lagging indicator instead of a leading indicator at that point. So, no, I think that's good examples on all these.
And
Yeah,
I mean, you can even relate these risk analysis to the previous two articles we even talked about with the,
yeah,
with the electricity, because I mean, we talked about already so many hazards that incorporated with
hmm,
the tanker and even just situating it on the road, the rechargers. I mean, that's a perfect way to use this risk analysis chart to
hmm,
categorize what you need to do before you can kind of go to the market with these things, and even especially
yeah,
obviously cost is going to be obviously one of those high risk things, but that's not really value because if you're doing a lot of improvement, you'll get funding for it and you get support. So I don't think cost is even though it's high, that may be a non-essential
right,
for it, but it's more or less what dangers are we
hmm.
giving by having these evolutions installed, whether it's the manufacturing field or even just transportation wise.
No, I agree with you. I very valid points. Valid points. So I think with that, that was a pretty good discussion. I appreciate the time today, and appreciate the conversation on to good valid points.
Rob, thank you. I mean, you had a lot of great ideas and a lot to say too. So it's definitely great to get both sides because I mean, I wasn't sure how it would have turned out. Or are you going to be pro and I was going to be con? But it's great that we kind of we had an open mind in
Right.
regards to all these topics, and we saw the pros and the cons, and
Hmm.
we saw the similarities that our ideas even had, between both of them, and we were able to kind of uniformly agree and disagree on certain things, and even just have a concrete way to really move forward with both all these items.
Yeah, no, I agree. So we'll try to touch base maybe next week. Do another round of this. So I
All
will
right, sounds good.
I'll do this recording and I'll upload. I think I'm just gonna create like a YouTube and I'll create it private and just so that way you and I can just share it and we can
Okay,
upload it to our sites from there.
awesome. All right, sounds great, Chris.
All right, David, stay in touch.
All right, you too. Take care. See you
Later.
next week.